Hello and welcome to this video. Today we're going to be doing a bit of a dive into some of the hardware that we use for putting things together to build the structural components, how it all goes together, and ultimately show some of the progress that we've been making on version 2. We tried to make things as simple as possible for our builds, focusing on quick connections and disconnection, rapid deployability, and modularity. We felt it would be a win if we could limit the number of different parts, leaning instead on standardized structural components, connectors, and fasteners. So that said, let's get started. Meet some of the hardware. It's crazy how much you can do with a 3D printer, but the limitations of build size and dimensional orientation complexity make building large or complex items nearly impossible on any reasonable budget. And that's why these parts are in place, starting with my favorite, 2020 T-slot extruded aluminum. Strong, lightweight, and easy to cut to length, 2020 T-slot is a definite go-to for rapid prototyping. Called 2020 because of its 20 by 20 millimeter profile, when combined with 3D printing, these structural components can vastly increase what the maker can create. 2020 T-slot works with a variety of specialized fasteners, but the one I use most to integrate with 3D printing are these hammerhead nuts. These nuts slide into the channel and lock into place when tightened, holding whatever you screw down to it firmly. The hammerhead nut sizes I use are metric M3, M4, and M5. Going along with the hammerhead nuts are the bolts that thread into them. Typically, I use hex head M3, M4, and M5 screws to correspond with the nut that I chose. I standardize on the hex head to minimize the number of tools that are required to work on any of the items that I make, keeping it simple, easy, and most importantly, fast. To demonstrate how 2020 T-slot can be integrated with a 3D printed design, I have a 3D printed elbow made out of ABS that I am connecting with an M4 hammerhead nut and a 7mm M4 hex head screw. Using this method, it is easy to connect and disconnect parts. I have designed a number of different connectors for use, and I am including the link to my Thingiverse page here and in the comments. There is a lot of hardware pre-built and designed to work with 2020 T-slot. Take this hinge for example. It connects directly to the extruded aluminum with 2 M5 hammerhead nuts and 2 M5 hex head screws, 7mm long. Items like this hinge vastly increase the extensibility of a project without having to create custom or one-off solutions that make duplication of the prototype difficult. Once the hinge is tightened down, it's secure and not going anywhere. It is important to note that the end of the extruded aluminum can be tapped to accept an M6 bolt, if you need it. Even when tapping aluminum, remember to use tap and die oil and always wear those safety goggles. Sometimes you may want to connect a 3D printed part directly to another 3D printed part, but without glue so that it can be taken apart later on. It's in cases like this that I use these brass knurled threaded inserts. I have them in various lengths in M2 through M5. I use thick ABS glue to insert these inserts permanently into a 3D print, allowing me to secure another part to it using corresponding fasteners. In a previous video, we had created ABS glue, and now we're getting to use it to secure this insert inside this part. To do this, I apply glue to the outside edge of the fastener. Note that I threaded a screw all the way through to the end of the fastener so that the glue could not be allowed to foul the threads. Once the glue has been applied, I finish up by putting a small amount on the inside of the hole. For those curious, I printed the hole 0.2 millimeter larger in diameter than the fastener itself. Once the glue has been applied, we'll push the fastener with the threaded screw into the prepared hole. The glue will make the fastener slide in easy, so go slow. Press it in, wobbling a bit as you go to ensure good glue coverage, until the insert is flush with the part. Then, use your putty knife to clean up any excess. Wait 24 hours for the glue to dry, and your part is ready for use. A few years ago, I picked up this metal bandsaw off of Amazon, and it has been just perfect. I use it at close to the lowest RPM as aluminum is very soft, and there's no reason to go fast. T-slot cuts easily with a tool like this. Always wear eye protection when cutting with power tools, and be careful of the metal filings as they can be sharp. It was about this time in the creation of this video that I realized I was going to need some focal point to bring all these details together. In the end, I decided to go with showing off my project cart, which I had built a few days previous. I had made it out of a kid's shopping cart. It was supposed to be a place where I could hang and work on my acrylic project board, where I would be mounting all of the electronics for version 2. This little stand contains all of the elements that I just went over. I think it's pretty cool how using 3D printed parts, we can create integrations between so many things. Mounting the 3D printed cleats that we earlier in this video had glued inserts into allows us to hang it into the project cart and ultimately into the Hydroponics version 2 chassis itself. It has connectors that are spaced exactly the same as the project cart, so once all of the electronics are hung and wired up, I can easily transfer it to the larger system. In the end, it's the quick connect capability designed into these blue cleats that allows us to move the electronics board around so easily, which is a win for us and any integrator. And here I am hanging the rails that will hold the project board under the hydroponics cart. I didn't particularly care for these hangers, so I built another set, and they're significantly more sturdy. Well, here we are at the end of another video. We covered a lot about build structure and went over some of the tools we use to put things together. It was fun making it, and we look forward to having another video with more project progress for you very soon. Thanks for watching.